Hello everybody, this is the video tutorial for the 7323 CAM Rev 0. And you should be able to import this SOLIDWORKS file. This one imported with the front facing away, so what we're going to do is we're going to look at it at this orientation, and we're going to do something here. Set our current view as home, and we're going to fit to view. Okay, and then now if we hit home, it'll return to that view. Okay, and we've imported this from SOLIDWORKS, and the naming convention's a little bit different. So what we want to do is we want to go to our file, right click, rename. You're going to put rev underscore 0 underscore your first initial and last name, and hit enter. Okay, and that way we got it in the proper naming convention. Now we're going to go get your stock that you modeled for this and should have already programmed is the different part number. It's the 7333 Rev 0. And we're going to pull that into this model. Okay, we're going to expand that model and we're going to hide the V block and the vise. We don't need those items. And let's drag this over and let's take a look at it in orientation to our part. And it looks like, to me, the pin is in the right place the way I modeled it. If it isn't for you, you'll need to rotate this so it does line up. We're going to hit OK. And I'm actually going to go to bodies and I'm going to hide what was the stock for the 7033. And this is actually what we're dealing with. The 7033 is now the stock for 7323. And what was labeled stock here was within that part. Okay, so now what we're going to do is we're going to go to assemble and we're going to do a joint, and we're going to pick similar surfaces. Okay, so whether they're edges or a surface, you need to pick with the same origin place. And again, if this pin doesn't line up, this is the point where you need to do a rotation to get that pin to match. Okay, we're going to hit OK. And I'm going to go back to my home position. And we should see a witness line of the finished part here, and this is actually a finished surface on the part as well. Okay, now what we need to do is we need to bring in our rotary axis. So we're going to go in and we're going to take our Sierra College HRT 160, bring that into the model as well. Mine happens to be orientated correctly with the pin in the up position. Doesn't necessarily mean yours is going to be. If you need to reorientate it, do it at this point. We're going to hit OK. Okay, so we're going to assemble these. We're going to go to Assemble, Joint, and on our fixture, we're going to pick the face where it's going to register. And we want it to snap point to the center of that diameter. Okay, and then on our part, it's not this boss. This boss goes down inside the fixture. We want this face to be the alignment because there's a 100 thousandths clearance designed in the fixture so that that boss doesn't bottom out. So we're going to pick the outside, or the chamfer that's at the top of the feature, and it should align like this. Okay, if you've done it right, you should be able to zoom in and see the chamfer still visible. If you didn't, you selected the wrong side of one of the chamfers on one of the two parts. Okay, next, go back to home. Next, we need to adjust the length of the shaft stick out, and so there's a dimension in the TRT and the HRT model that can be changed for that. So temporarily, we're going to hide both the model of the stock and the model of the part itself. And if you zoom out, you should see some numbers appear. It's unfortunate Fusion does it this way, but we double click on it, and we need to make this number 2.51. And that should put this at the distance of the face of this nut right at the end of our part. So let's make that visible, the part visible again, and see if it is. And it should be. Okay. Okay, now we're going to go ahead and turn our 7333 back on. This is what it should look like. Make sure you've saved. Okay, so we're going to go from design to manufacture. And it's going to pop up with this window, insert manufacturing data. That's from your 7333 part. We don't want that, so we're going to hit cancel. Now we're going to create our setup. So we're going to go new setup. And it's initially going to try to make the stock the entire assembly. That's not what we want. We're going to go to expand our models. Expand the 7333 as well so we can see both the bodies. And our model is going to be the 7323 model. And then we're going to go to the stock tab and we're going to change this from relative size box to solid. And we're going to select the 7333 model. It should say 3 inches in all of these boxes. Then we can go back to our previous tab and we're going to change the orientation to Z-axis plane and X-axis. Select the top of the rotary. Select a line that's in the X-axis for the rotary. And our origin is going to be model box point. And we're going to select the one that's at the center front of our workpiece. We're going to go to the post-processing tab and we're going to number this 7323 first operation, op 1, work coordinate system 2. Make sure you're using work coordinate system 2, that's G55. We're going to select OK. Now we're going to go to the setup and we're going to type op 1 and we're going to go ahead and put a note for axis so that when we're post-processing we know whether this is a 3-axis, 4-axis, or 5-axis routine. And we should be good to go. We no longer need the model visible for the 7333. The information is now embedded in the stock. And so we're going to collapse all this down. We shouldn't have to turn that back on. Now in this project we're going to cycle through what are the rotary commands. They're called multi-axis, but they're pretty much only used to spin apart in a rotary axis. So the function actually is 4-axis. The 5th axis capability of it is able to tilt that axis so that you could say do a cone. But in essence, this works the same in 4 and 5 axis. So it's truly more of a 4th axis type of command, but used often on a 5 axis. Okay, so we're going to go to rotary pocket. That's our first one. That is the closest thing we have to a true roughing cycle that can take off different depths. There's rotary parallel, contour. Okay, we've already set up our stock. And we're going to start with a rotary pocket. So we're going to go to multi-axis and we're going to select rotary pocket. Rotary pocket is good for removing lots of material. Typically roughing passes. And on parts that have, say, prismatic features, like this does on a cylindrical type body. Okay, we're going to select our tool from our tool library and we're going to select the 1/2-inch end mill. Okay, our default feeds and speeds are pretty good, but for this we're going to bump up our RPM about 500. A little bit faster spin on it. We're doing mostly roughing with this. And then we'll leave everything on that page at default. We're going to go to the multi-axis tab. And so for 3-axis stuff, you don't use this, but we're going to set up our rotary axis. And we have different options here. If you've already done your setup, you could do setup with X-axis of the rotary, which was based off your operation. So that's usually the best. Our rotary origin, we're just going to set it up WCS origin. We're going to leave that where it is. So it is going to base all that off the setup. If your setup's not done correctly, you're going to have issues. We're going to move on to the geometry tab. And we're going to go selection for the front, which is going to be the face of the part. And the back is going to be selection. And we're going to select either the face or this diameter as the other end of what we're machining. And now we're going to go on to the radii tab. And it's asking what are the faces we're going to machine in between. So this is kind of like height on a prismatic part. The light blue is where we're going to start machining. The dark blue is where we're going to end machining. We don't want to go to this center diameter. We don't want to machine into this bolt. We are going to go from stock ID, and then our inside diameter is going to be based off selection, which we're going to select this smallest diameter that we want to machine. And so it shouldn't process anything narrower than what we just selected there. We're going to go to passes tab. And we're going to have a maximum step of a 1/4 of an inch. So 0.25. And we want order by depth. And our tool offset, what this does is it offsets the diameter of the tool. And this only works in 4 and 5 axis, but that way you can use the cutting flute to do the majority of the cutting without the center rubbing. And it's more efficient. So we're going to go half the diameter of the tool, 0.25. And we're going to do automatic step downs, and our maximum step down is going to be also a 1/4 of an inch. This is roughing. And we do want to step on floors. Okay. And beyond limit should be checked for the front, but the back we don't want to go past the limit because we'd run into our fixture. Our stock to leave is going to be 40 thousandths. That's about approximately a millimeter, and that's typically what I leave for a finish cut to be removed in aluminum. Okay, and our smoothing, we're going to do 10 thousandths. We want it to go a little faster, so it's moving around its profiles. The rest of the options on here we're going to leave as is. Go to the linking tab, and the only thing we're going to do here is we're going to bump our ramp angle up to 3 degrees. And the reason I'm doing that, when I processed this before, it was taking a lot of time doing a zigzag just for 2 features, and it knocked almost 3 minutes off the part by having the ramp angle different. It changes how it approaches plunging into the material. Okay, we're going to hit OK. And this is what our process should look like. So it's going to come around, it's going to take the diameter down by about a 1/4 of an inch, then it's going to start doing pockets, relieving the material where that particular cutter can fit. Okay, we're going to move on to the next operation. That's a pretty big cutter, so if you saw, it's not cutting a lot of the cavities in here. So we're going to go and we're going to duplicate this same routine so we can use most of the same settings. And we're going to go down a diameter. So we're going to duplicate this, we're going to edit it, and we're going to select from our library the 1/4 inch end mill. Now, this is a pretty common methodology for doing surface type machining where you step down in diameter, because each progressive cutter takes a smaller radius out. Okay, just like on the last one, we're going to bump the RPM up on this. We're going to go 6,000 and 6,000. Okay. And we should have 27 inches a minute or so. And we're going to go over to the multi-axis tab. This should be already set up. Okay, so we go to the geometry tab, and our front of our model is going to be selecting the front face, and the back of our model we're going to select either the face of this or this edge here, either way, and that sets what our front and back of the model is. We also want to check this rest machining box. What this does is, in theory, will only machine material where the previous cutter hasn't removed it, so it saves lots of time. And we're going to select the radii tab. Instead of going from the stock diameter, we're going to go from model diameter, model OD. The reason is we've already removed all the diameter from the stock, so we don't want to waste time cutting air there. Okay, and then we're going to go to the linking tab. We're going to change, the 0.125 is fine for step down, but on our tool offset, 1/4 of an inch is bigger than the diameter of the cutter, so we're going to change that to 1/8 of an inch, which is half the diameter of the cutter. And our maximum step down, we're going to reduce that to 0.125 as well. So we're going to get a stair-step topography type effect on this, and we're creating a higher resolution by going to the next cutter. And we're going to leave all of this at default. Just make sure that this ramping angle is at 2 degrees. We modified it for the last one, but 2 degrees is fine. All right, we're going to go ahead and hit OK. Anytime we use rest machining, the order in which the routines are in matters, and it references the previous one, so it takes a little bit of time to regenerate. And every time you regenerate its predecessor, you're going to have to regenerate all of the ones that follow. Now, something I notice is the rapids are frequent. They retract quite a bit. If I was in a production shop, I would probably dial this in to be shorter, but since we're a school, we're okay. We're going to leave it just the way it is. Okay, we're going to move on to the next one, which is going to be another rotary pocket. Before I go any farther, I'm going to rename these so that they match the handout. So it's rotary pocket 1, rotary pocket 2, and you notice just even renaming them causes them to regenerate. So now what we're going to do is we're going to do another rotary pocket, but this one's going to be contained to just cutting this slot. And this is the type of feature that rotary pocket does well with, but we have to contain it between these two faces. And we're going to do basically a finish cut on these sides and this fillet with this command. We will still need to come in and cut this surface with another command. So here's how we approach this. We're going to do I'm going to go ahead and select a new rotary pocket command. And we're going to select a different cutter. We're going to use the 1/4 inch ball cutter so that we can cut that fillet. That's tool number 6. Following suit with the other ones, we're going to bump this up in RPM. 6,000. 6,000. And I noticed an issue with our tool library. It's defaulting to a cutting feed rate that's actually slower than the lead-in rate. We're going to actually bump that up to 27 inches a minute. It's possible by the time you see this video that's been corrected in the next version of the tool library. Okay, so that should be 27 inches a minute. Okay, we're going to go to the next tab, and we're going to put this on setup with x-axis with our setup of the rotary. We move on to the next tab. Okay, on geometry, we're going to pick the faces we're going to machine. So instead of stock mode, we're going to go to selection. And the front is going to be this face here of the slot. And the back is going to be the back side of the slot. So we're containing the machining between these two faces. It's going to start on the left, work towards the right. On this, we also want to select rest machining. It should reduce the amount of tool path created. And on these faces, we want to cut right to them. We don't want to have them offset. So in both these boxes, the first one you're going to put 0.125, and on the other side we're going to put negative 0.125. And that'll ensure it actually cuts the face and doesn't avoid the face of the material. Okay, next we're going to move on to the radii tab, and it defaults to stock OD. We're going to change that to selection, and we're going to select the outer circle of the grip. We're going to put 0 on offset. So that's where the diameter we're going to start our machining at. And then we're not going to the stock ID. We're going to go to selection. And we're going to pick the floor of the slot. We are going to put in a little bit of clearance of 0.010. We are going to come back with the same ball cutter and cut the part that's highlighted in blue, that little shank. So we want to make sure we're not gouging into it when the cutter's under more load, and then it'll recut the fillet with a very light finish cut. We're moving on to the next tab, passes. 125, we only want to climb cut. Our tool offset, we want to increase that to 0.125. In this case, I don't want to do automatic step downs. We want to do a known amount, and it's going to be 0.15. Now that seems like a lot, but we're not cutting a surface. We're trying to cut just the faces of those materials. So we're using a command that's typically used for surfacing. We do want to have a step down on the floor, and we want to deselect the beyond front limits, and we're going to deselect stock to leaf. The rest of these boxes can be left unchecked. Now we'll go to the linking tab, and the only thing we're going to deselect is this beyond front limit. We don't want it leading in through these cavities here, and it'll gouge the fillet on the top. Then we're going to hit OK. Okay, so the way this functions, it should be going around and skimming the wall, bringing it to final finish. And it does look like I got one move in the middle, which I was not exactly wanting, but I guess it'll be an additional roughing cut. Okay, next operation. We're going to do what's called a rotary contour. As you can see, this is very stair-steppy. It's not very consistent on how much material is being left. So if I were to look at this cone, we got a variable amount of material between the cone shape and these staggered cuts we've made with the flat end mill. We're going to come back with another roughing cut with a ball cutter to get it closer to this shape, leaving 40 thousandths to be removed by the very last routine that's going to take it down to final. So the command we're going to use on that is called a rotary contour. It's better for cutting along surfaces like this. If you're doing an impeller, you might use it for the fins, but still need to come in and rough ahead of time and do something else for the floors. Okay, so we're going to go to multi-axis. We're going to do rotary contour. And on this one, again, we're going to bump up our feed rate. It's going to be 6,000 RPM. Make sure this feed rate here is 27 inches a minute. The rest of that tab can be left as is. We're going to go to the multi-axis tab, and again, we're going to go to set up x-axis as the axis of rotation. We're going to go to geometry. And for this, we're going to select geometry. We're going to select the faces. So we're going to pick this as the front. And we're going to select this surface or this edge as the back. We're now going to go to the radii tab, and our stock OD is not going to be where we want to start. We want to use selection, and we're going to pick this diameter here. That's the limits of where we want to start, and where we want to finish is not the hole in the center of the part. It is the shank of this diameter here. Next, we're going to go to the passes tab. We're going to do 60 thousandths step downs. This is a roughing routine. We do want to do a step down on floors. We do want to go beyond the front limit. We do not want to go beyond the back limit. Our stock to leave is going to be the same as the other operations at 40 thousandths. We are going to check the smoothing box and we'll leave it at 20 thousandths is fine. The other boxes we're going to leave at default. We're going to go to the linking tab. We're going to leave all that at default. Okay. This one will take a little time to process. Okay, so you can see it comes in and does this scallop like work. And that should remove a lot of the steps left by the previous operation, knocking down all the high spots so that when our finish cutter comes in, it's on a relatively consistent load. Our last routine is rotary parallel. It's typically used for finishing. Okay, and this one we're going to try to go as fast as the rotary can go. Now, I realized after we ran this once, our rotary is actually not capable of going this feed rate, but if we had a SS model, we could go this fast, and these would be typical finish cut feed rates for a ball cutter only taking a millimeter off. You could go 8,000 RPM, but I try to avoid going at maximum of our RPM for long durations of a time. Our machines go 8,100 RPM. Also on this type of routine, the ramp and the plunge rates are more or less horizontal moves, and so they don't operate like other commands. So we're going to bump those up to 40 inches a minute. Again, the rotary spins somewhere around 25, 20, so the time estimate's going to be significantly off for this routine. And let's make sure we've got them all at 40. Okay, we're going to go to our next tab, and we're going to set up our rotary axis is going to be from our setup, pretty consistent. And the back reference is going to be either this face or this edge of the model. The front of the model's here. So between the orange and the, I don't know, mustard colored rings. Okay, we're going to go to radii. And we're going to set this to model OD. We're going to cut the entire model diameter. And we're going to set the outer clearance also to model OD. We're going to leave everything at default there. We're going to go to the next tab, which is the passes tab. And we're going to do a step over of 0.015. Now the last time we taught the class we did 10 thou and it ran too long. So this should cut 50% off the runtime. Typically if I was cutting this in the shop and I had all the hours I needed to run it overnight, I might actually go tighter than that. You can set a cusp height. This should in theory give you a consistent height of scallop. And this works out to about a cusp height of 5 thousandths. But we're just going to set it at this. We need to be able to get this done in one lab period. Okay, and we're going to do spiral style. And then we're going to do a tool offset of negative 0.125. When I set this up as positive, it was tilting the cutter the wrong way. We want to be leading into the material, not trailing it as we climb cut. So I'm not sure the reason for that, but you're going to want to look at your tool path from the front, which I'll do at the end here, so that you can see that the cutter is leading into the material at an angle so that the tip is pointing away from the part. Okay, so I'm not sure why that happened. On my other commands, a positive value worked. Okay, we're going to the next tab, which is our linking tab, and we can leave those at default. We're going to hit OK. Okay, and your resultant should look like this. Now let's take a look at what I was talking about the lead-in. Every time you program something, you want to check it. So if I put a positive value in, it comes on the opposite side of the radius, and you see how the cutter is tilted. The whole goal is to have the tip of this tool leading away from the radius and having the cutting action being done by the leading edge of the ball cutter. For some reason, when I put in a positive lead on this one command, it put it over here so that it would be cutting on the trailing edge of the cutter. So anyway, watch out for that. It's not how I predicted the command would work, and it was inconsistent with the other ones. All right, that's it for programming this part. Make sure you do all the things you need to do to submit your assignment.